Okay, this is additional content for perhaps your finals preparation. Um, I will try first number 10, point B. So we have two paraboloids, z equal 6 minus x squared minus y squared, and then z equal to x squared plus 2y squared. Okay, if you want, you can try to perhaps try to draw. But if you want to draw, and perhaps this is a rough sketch of how it's going to be. So it's going to be like this. It's going to be like this. So this one here is the blue one, 6 minus x squared minus y squared, because it has minus and minus. Okay, so it's supposed to be having upside down curve. Okay, but the one thing that I want to explain here is these two curve at one point, these two z, they will intersect each other. Okay, so I think we could look that first and then see what is the equation. So let these two intersect, so intersection both between paraboloids. Right, this is equal to 2x squared plus 2y squared. Okay, so x squared plus y squared, okay, after we simplified, is equal, oh, 3, sorry, it's supposed to be 3. 3 is equal 6, so x squared plus y squared is 2, okay? So this is the intersection between these two paraboloids, which means that in this point here that is going to be intersected, we will see that we have a circle here. We will see the circle that is this one, okay? And this red circle will be our projection area from this volume. Then we take this double integration of this area, and then the volume will be the subtraction between these two paraboloids. The circle here and paraboloids here, they all have something in common, which is polar equations. So to solve this, it perhaps easier to solve using polar coordinates. So looking at this equation here, so this will be a circle, right, with a radius square root of 2. And the circle will be moving through all the theta, the angle. So we are going to see that the angle is from 0 to 2 pi, and then the r is from 0 to the square root of 2, right? Okay, now we can plug in into the system, and then we can convert all to polar. So this will be r squared. Or if you want, we can solve this first. Let me solve this first. So 6 minus 3x squared minus 3y squared, or 6 minus 3x squared plus y squared, okay? And then this x squared plus y squared is r squared, so we can write 6 minus 3 r squared, okay, and then r dr d theta, okay? So don't forget that there is a bracket there. We need to multiply r with both numbers. So 6r minus 3r cubed dr d theta. Okay, we can solve the d theta first if you want. We can write that 2 pi in the front, and then we can just integrate as usual. This is 3r squared. This is r4. Sorry, not r4. 3 over 4 r4, and then 0 square root of 2. So this will be 2 pi square root of 2, 6, right? 6 minus what? 3, right? And this will be 6 pi. Okay. Okay. Now let's see the next one here. So use the given transformation to evaluate the integral. So let's say we are going to solve, I think, number A. Okay. How about that? So you can pause the video and then we can start to solve it together. Okay, so let's solve number A. So we have double integral x squared dA, and then we have the transformation for x equal to u, and y is 3v. And we have the boundary is the ellipse, that is 9x squared plus 4y squared equal 36. Okay, now what is this? Okay, so if we just checking the transformation and then see what we have in our ellipse. So perhaps if we try to just try to take this into our equations. Okay, so the transformation from xy to uv, we can rewrite that as or we can write that this u squared plus v squared is equal 1. So the boundary is actually limited by a circle that has radius 1. Okay, if we want to transform this xy to uv. So I think this perfect transitions, perfect transformations, right? So what happens next is we can start to maybe first taking the Jacobian transformation. So taking from xy to uv. So we only have these transformations, right? So x equal to u and y equal to v, 3v, right? So this will be, I think we can rewrite this. And if you forget that this is del x del u, del x del v, del y del u, del y del v. And then we can take that. Gonna maybe make it a little bit to the left. So the x del u, it's 2. And then the x del v, it's 0 because no v in that equations. The y del u is 0, it's 3. Okay. And then take the determinant, this is equal to 6. So the Jacobian transformations constant is 6. Okay. And then we can take that into our transformation. So we can write the x using the 2u. So we can write, or let me just write again. This is the question. Okay. And then our boundary is this circle. And then we have the x squared here that has transformations to 2u. So 2u squared, so become 4u squared. Okay. And then multiply with the Jacobian 6. And then we can just write first the UDV. Write first the UDV. We can force this out, taking the u and v, using this circle like this. So we can take maybe u is from 0 to 1, and then v is from 0 to this equation here, which is v is square root of 1 minus u squared. But I think this will be a little bit complicated if we force this out. So one possible method is to convert from this uv, convert to r theta. So again, this will be conversion, convert to polar. Okay. So we see that the circle is a whole circle, the full circle, so 0 to 2 pi, right? So we can write that 0, theta, 2 pi, and then we have 0, r, and then 1. So just this, right? Okay, and then we can rewrite u as a r cosine theta, and then v r sine theta. Okay, just like x and y. Okay, and then this is 0 to pi, 0, 1, and then this is 24, and then u squared becomes this r squared cos squared theta. Okay, and then r dr d theta. Okay, I think we can separate r and theta. So let me write 24 in the front. This 0 to pi cos squared theta d theta, and then r cubed dr from 0 to 1. Okay. Now cos squared theta, we can take the double angle. So this will be cos squared alpha equal half cos 2 alpha plus half, right? So let me write. Okay. Now this will be half theta plus cosine becomes sine, so sine 2 theta over 4, right? And then this is from 0 to 2 pi, and then again still multiply with 1 over 4 r with power of 4 from 0 to 1. Okay, this will be 0, right? From 2 pi, and then 0 is still 0, so this will be 2 pi. So this will be pi. So this will be pi over 4 multiply. So pi over 4 multiplied with 24, or 6 pi. Okay. Okay, that's it for these two questions. Okay. You could try the same thing for number B. Okay, hopefully you get the idea. Okay, and I think for number B, you can directly write and then just directly integrate after transformation. You no need to convert to polar. I think you can just directly transform and integrate. Okay.